let's continue building our skills on multiplication, but I also want to kind of bring forth how the distributive property can be used to help us do multiplying when the numbers start to get larger. So I'm going to start out with some small numbers to start with, just to make sure we're on the same page with some of the math facts. So, remember 6 times 7 just means 6 sevens. So if I was using my, remember the tic-tac-toe board helps me do the sevens. So if I make my tic-tac-toe board, remember you start in the top right-hand corner, you go 1, 2, 3, then there's 4, 5, and 6, and then I got those two close to the side there. Let me undo that. So I need to stay on the right-hand side. So 4, 5, and 6, 7, 8, 9. Because remember, when I go across this way, I got to put front numbers in. So 0, 1, 2, 2, 3, 4, 4, 5, 6. So we need 6 times 7, so we need the sixth fact. So 1, 2, 3, 4, 5. The sixth fact would be 42. So we know 6 times 7 is 42 by just knowing our math facts. Now, let's do the problem a different way. This time, let's do this as a distributive property problem. Now, remember, distributive property involves multiplying with respect to addition or subtraction. So I'm going to keep the 6, but what I want to do is I want to change the 7 into an addition problem. It doesn't matter what numbers you use. I'm going to think of like 5 plus 2 makes 7. A lot of times I think in terms of money. You can use a $5 bill and then 2 ones to make $7. So the 5 kind of jumps out at me because I'm thinking about money. So when I do this, notice how this 6 must multiply to each addition piece. So the 6 has to multiply to the 5, and the 6 has to multiply to the 2. So what we refer to as we distributed through the parentheses. So when I do that, our problem then turns into, we have this 6 times 5 plus then this 6 times 2 comes into power. So then we do each multiplication piece. We know that 6 times 5, instead of saying, well, you can say 6 5, so it'd be like 5, 10, 15, 20, 25, 30. So 6 5s would be 30. And then you would add to that, 6 2s. So if you count by 2s, that'd be like 2, 4, 6, 8, 10, 12. So that would be a 12. And then if we want, we can add 30 plus 12. And notice how you have 3 10s and 1 10 and 0 1s and 2 1s. Or if you want, you can just use the algorithm of lining up your place values in column form. 0 1s plus 2 1s is 2 1s, and 3 10s plus 1 10 is 4 10s, and you would get 42. So notice that the distributive property works the problem out a little bit differently, but it would still give me the same answer. Let's look at this 8 times 9. So remember, distributive property also works with subtraction. And when I think of 9 as a subtraction problem, 9 is really close to 10. So if I'm at 10 and take away 1, that's going to bring me back to 9. Let me fix that. Use red there. So it's going to be 10 minus 1. So again, the distributive property allows me to multiply the 8 through the subtraction. So this turns into 2 multiplications to start with. So when I do that math, I have to multiply the 8 to the 10, so it's going to be 8 times 10. And I also got to multiply, oops, this is subtraction. Back up again. Got to pay attention. We are subtracting this time. And then 8 times 1 would be my next piece. So then when I do my multiplication, 8 times 10, 8 tens, 10, 20, 30, 40, 50, 60, 70, 80. We also know that when you multiply by 10, all you got to do is add a 0. So that's 80. Minus then 8 times 1, well, 8 ones is just 8. And then 80 minus 8. Again, if you want to use the subtraction algorithm, so you have the 80 minus the 8. And notice that we don't have any ones here, so I have to borrow. So that turns that into 7 tens. And when I bring over a 10 to the 1 spot, that turns that into 10 ones. So 10 ones, take 8 ones, that's going to give me 2. And then the 7 would just come down. So you'd end up with 72. That's using the distributive property of the answer. But also notice that 8 nines, I could have used our 9 trick. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm looking for the 8th fact. So 1, 2, 3, 4, 5, 6, 7. The 8th fact would be that 72. So there's a couple ways to actually do 8 times 9. One is knowing the actual facts, but also the distributive property can be used to do the math as well. So 2 times 43, remember 2 43s means 43 plus 43. So one way to do the problem is just write down 43 plus 43. Because 2 43s just means you're adding 2 43s. So 3 ones plus 3 ones makes 6 ones. And 4 tens plus 4 tens is going to give me 8 tens. So the answer would be 86. Now, I can also use the distributive property there. I think that's one of the reasons we start to use parentheses for multiplication, because when you use parentheses for multiplication, it helps you remember that you could be using the distributive property. So I have this 2, and then in parentheses, using place value, this 4 means 4D, so 4 tens or 40, plus then 3 ones, or simply 3. So I can break it apart as an addition problem using place value. That's that expanded form stuff. So now I'm allowed to use the distributive property, because you've got to have addition and multiplication present. So the 2 can multiply through the addition. So it multiplies to the 40 and the 3. So what we have now is 2 times 40 plus 2 times 3. And remember, when you have a trailing 0, you can ignore it. You can just simply say, well, 2 times 4 is 8, and then bring down the trailing 0. So that turns into 80. Plus then, 2 times 3 is then 6. And then 80 plus 6 turns into 86. So that's using the distributive property to do multiplication. And what we'll find out is the algorithm that we're going to be working on, it's going to be more what we call the distributive property. So see if we can kind of work our way towards that.